Let us solve few problems related to equations of, and we use all the expressions we have derived. An aircraft is flying at a speed of 500 feet per second. So V infinity is 500 feet per second at an altitude of 30,000 feet. So which is 30,000 feet. And they have specified density at that altitude, which is 8.9068 feet cube. Apart from this data, they have given the aircraft data, that is, what is the weight of the aircraft, which is 73,000 pounds. Wingspan area, aspect ratio, CD0, and K. So these are the given. So we need to find what is the thrust required. Now we know CD is given by CD naught plus KCL square. CL is 2W by rho square into S. So the first step will be to calculate CL from given variables, like we know W, rho, V infinity and S. V infinity, rho, W and S. Using this, we'll obtain CL as 0.6902. Now using this CL here, and K is given, CD0 is given, we get CD equal to 0.31. So we know CL and CD. The thrust required is equal to drag. So we can put half rho V square S into CD. Now we know CD. So using that, we obtain 617 pounds. So using these three relations, we have found what is the thrust required for this aircraft. For the same problem, if they ask you to find what is the minimum thrust required, then we know the formula. Root of CD0 into K. So this multiply by weight to give 50 by weight pounds. And they have asked you also find the corresponding velocity. Corresponding velocity to this. So you can put V TR min. So to find V TR min, let us find the other design parameter we have discussed, which is the wing loading, W by S. We know W and we know S. So it is W by S is 76.84 square. So we know TR min, or in fact TR by W and W by S. And the relation is V TR min is now we know the wing loading, we know K, CD naught and 2 infinity. Using that we have taken it is 631 into feet per second. So this for the same question previously we solved what is the thrust required. Now they have asked what is the minimum thrust required and the corresponding velocity. Now let us solve few gate questions. The question is, an aircraft is cruising at true airspeed of 100 meters per second under standard condition at an altitude at which density is given. What is the equivalent airspeed? Okay. So the aircraft is cruising at true airspeed of, so VTAS is given as 100 meters per second under standard condition. That means also they are given the density, right, that which is joules 0.526 kg per meter cube. So we need to find what is the equivalent airspeed. And we already know what is the relation. VEAS is root of rho by rho sea level into VTAS. So we know VTAS, rho, and let us use the sea level altitude. Will give 65.5 meters per second. So they are given the options 65.5, 72.5, 110.5, 152. So the correct answer is 65.5. This is your equivalent answer. The next question, they have given these data like CD naught is 0.0223, aspect ratio is 10, Oswald efficiency factor is 0.7. Need to obtain what is the CL. Okay. Now we can find what is in the relation. K is 1 by IE AR. So we know AR, we know E. Substituting that, we get K as 0.0455. Now using the expression CL equal to root of CD naught by K, and now we know CD naught and this K is 0.7. They are given options 0.65, 0.7, 0.75, 0.8. The correct answer is 0.7. So here we have found what is the CL at minimum TR. Here they have given four options. It is VAS, VTAS, sigma, So these are the relation between VEAS and VTAS, and they are asked which one is correct. We all know V equivalent as speed is root of sigma into VTAS, where sigma is rho by rho S. So this one is correct. So in the next class we'll start stirring velocity. We'll look into high lift devices and we'll move on to climbing performance.